Here's a good Halloween trick. Buy a bunch of Reese's. There you go. Turn off all the lights in your house. Yeah. And then you just don't answer the door. Not sorry, Reese's. Is it too early to start celebrating Halloween? Well, if you're celebrating by eating Reese's, then no. You're actually late. Not sorry, Reese's.
Reese's how it's made. Imagine 2 million peanuts thundering into a machine. And seconds later, perfectly shaped chocolate cups roll out 800 pairs every minute. The part that makes the flavor unforgettable? It started with an accident. Today, we're going inside the line to reveal the precise choreography behind the world's most famous peanut butter cup and the tiny tweaks that make it taste exactly the same every single time. By the end of this video, you'll know why the chocolate cracks with that clean snap, what gives the peanut butter its gritty smooth bite, and how a factory can turn raw farm crops into a candy icon at industrial scale. Stick around for 3. Blink and you'll miss them. Moments on the line that decide whether a cup becomes perfect or becomes scrap. Before conveyor belts and robotic claws, there was a basement workshop. In 1928, H.B. Reese, former dairy farm hand and chocolate factory foreman, started molding chocolate around a salty sweet peanut butter filling. It was humble, hand-scaled, and wildly popular. That little penny cup would one day grow into a multi-billion-dollar franchise, and the way it's made today is a masterclass in repeatable engineering. The charm of the original is still there, but now it's delivered by a system that never gets tired. Feeders, blenders, roasters, refiners, extruders, tempering tanks, and cooling tunnels. The mission hasn't changed. Deliver that exact flavor memory every time. Only the tools have. In a moment, we'll see how a tiny too hot mishap from the early days turned into a flavor signature the brand protects like a secret handshake. Every week, trucks arrive loaded with super sacks of runner peanuts from the southeastern U.S. Each bag can tip the scales at roughly 2,500 pounds over a ton of peanuts in one go. Forklifts hoist the sacks over a hopper. A worker releases the chute, and gravity does the rest. A nutty avalanche roars into the system. Inside, a vibrating deck shakes away stowaway stones and shell fragments, while a bucket elevator lifts clean peanuts to the roaster. It's a simple rule with industrial steaks: garbage in, garbage out. If you don't start with clean, consistent nuts, you won't end with consistent cups. Coming up, the roaster runs a temperature schedule that sounds wrong on paper until you taste it. The roaster is a long, heated tunnel, dry heat, carefully profiled. The target is around the high 200 degrees Fahrenheit for roughly half an hour. Why so specific? Roasting triggers the Maillard reaction proteins and sugars in peanuts brown, unlocking deep, toasted flavors. Here's the twist. The peanut butter you know is famous for a slightly granular, bold, nutty character. That came from an early over-roast. A faulty roaster ran hotter than planned. The batch should have been a write-off, but it tasted incredible. That oops became encoded into the process as a controlled push toward the edge. Never burnt, never raw, just a notch past safe. That tiny push does 2 things. It drives off a bit more moisture for texture, and it intensifies the roasted aroma, so the peanut character cuts through the chocolate instead of getting lost. In a second, we'll grind these peanuts and you'll hear about the millimeters that matter. Roasted peanuts tumble into a blancher. A rough, vibrating belt loosens the papery skins. Air jets whisk them away. Then comes the grinder, 2 steel plates spinning just millimeters apart. That gap setting determines texture. Too wide, and you get coarse paste that won't pipe cleanly. Too tight and friction overheats the peanut oils, dulling flavor. The sweet spot gives a warm, flowing butter with enough body to stand up inside chocolate. The butter is pumped through stainless plumbing to mixing tanks where the base is tuned. Salt for pop, sugar for balance, stabilizing fat to keep oil from separating, and a touch of dextrose to amplify the roasted notes. Think of dextrose like a spotlight for peanut flavor. It doesn't shout. It makes the star easier to see. The next machine is a giant vacuum that literally slurps barrels of peanut butter off the floor. Yes, on purpose. Large drums of peanut butter are staged on the lower level. A vacuum wand drops in, and in seconds, a tank upstairs begins to fill. No mess, no air pockets. Inside the mixer, paddles fold in powdered sugar, a pinch of salt, and emulsifiers. The goal isn't peanut butter for toast. It's filling firmer, sweeter, more structured, so it slices cleanly and holds shape when enrobed in chocolate. If the filling's too soft, it slumps and smears. Too dry, it crumbles and leaves voids. This texture target is tested constantly. Operators check viscosity, temperature, and even the way the filling breaks when pulled up by a spatula. It has to land in the Goldilocks zone, so the next step can do its magic in milliseconds. Speaking of magic, let's switch to the chocolate side. We're about to make crumb, a sandy powder that somehow becomes silk. Chocolate starts with cocoa beans, sugar, milk, and cocoa butter. At this factory, those ingredients become a dry mixture called crumb. Imagine chocolate-flavored wet sand. That crumb is refined down to ultra-fine particles, then conched, mixed, and aerated until it transforms back into a flowing, glossy liquid. But the real make-or-break moment is tempering. Chocolate fat, cocoa butter, crystallizes in several forms. Only one gives you that shiny finish and crisp snap. The tempering system cools and reheats the chocolate through a precise curve, so the right crystals dominate. Miss the curve, and your cups bloom, dull, or bend instead of snap. Nail it, and you get that glassy top and clean bite every time. Now the chocolate and the filling will finally meet, but only if a rain of paper cups lands perfectly first. Paper liners drop into slotted trays riding a wide conveyor. The placement looks simple, but it's critical. Double-up liners or tilted cups create weak walls. Line attendants scan for misfeeds and pluck out mistakes in real time, one of the last human touch points before a fully automated ballet. Up above, a towering depositor holds tempered chocolate at the perfect working temperature. As trays glide underneath, rows of nozzles pulse out identical shots, creating a base puddle of chocolate in each liner. A blast of air and a controlled jiggle from the conveyor spread the chocolate up the sides, forming that familiar cup wall. Too much air, and chocolate climbs too high. Too little, and the sides are thin and tear when you unwrap. This whole coat the walls moment takes seconds, but it sets the stage for everything that follows. Coming up next, the extruder, the machine that cuts peanut butter at the speed of a camera shutter. From the floor above, thick peanut filling feeds into an extruder. Picture a row of circular tubes pointing straight down at the moving cups. Pistons push, and perfect cylinders of filling exit each tube. A sharp blade kisses the stream and schwick, a plug drops, landing dead center in a chocolate-lined cup. The timing is outrageous. Conveyor speed, piston stroke, and blade timing must all sync within fractions of a second. If the plug is a millimeter off-center, the top chocolate won't seal evenly, creating thin spots or exposed filling. Operators run frequent checks, weight, diameter, placement to keep the line on target. There's a mesmerizing cadence to it. Pour, air, vibrate, schwick, glide. It's factory ASMR at scale. One more chocolate rain, and then we'll test the snap. A second depositor lays down the top chocolate. Another quick air pass erases ripples and tiny peaks, leaving a mirror-smooth surface. At this stage, the cup is structurally complete but still warm. Warm chocolate is tender. Breathe on it wrong and you'll leave a mark. So, the line sends trays into a long, chilled tunnel where time and temperature finish the job. Why a tunnel? Controlled crystallization. Inside, the cups spend roughly half an hour at cool but not freezing conditions, so the cocoa butter crystals lock into the right form and the filling firms up without sweating. On the other side, we'll meet a robot that plucks cups like a claw machine, only this one never misses. Cups exit the tunnel and slide toward a demolder. A neat array of robotic fingers lifts each one from its tray and sets it onto a conveyor. A rotating carousel groups them into pairs because really, who eats just one? Next comes the fame, that unmistakable orange wrapper. The flow wrapper feeds film, forms pouches, drops in 2 cups, and heat seals at breathtaking speed. A well-tuned line can crank out on the order of hundreds of pairs per minute, marching into cartons with military precision. But it's not ship it and forget it. Some cups won't make the cut, and that's intentional. Quality control is everywhere. Inline weigh cells reject packs that are even a few grams off spec. Metal detectors scan for stray fragments from machinery. Vision systems, high-speed cameras inspect seals, check print codes, and confirm every wrapper is closed and centered. Random samples are pulled to a lab every shift. Technicians snap cups to check temper, measure moisture, and even taste for flavor drift. If the peanut butter is a touch too dry or the chocolate's viscosity creeps, supervisors dial in small adjustments. A degree here, a minute there. The goal is ruthless consistency without losing that roasted peanut soul. You've seen the classic cup, but the line can morph. Up next, how the same factory makes big cup, minis, and seasonal shapes without losing that snap. Big cup uses deeper molds and a thicker filling cut timings change, blade stroke changes, and the top pour volume increases to seal the extra height. Minis skip paper liners altogether and run through different enrobing or molding steps to keep speed high without hand unwrapping frustrations. Seasonal shapes, pumpkins, trees introduce more complex cavities that challenge air removal and edge definition. Temper and vibration get tweaked, so details stay sharp. But every variant protects the core experience. Roasted, forward filling against a properly tempered shell. It's a moving target across sizes and seasons, and that's why the factory leans on sensors and routine tastings like a restaurant line lean on mise en place. What about freshness? Let's track a pack from line to shelf. Freshly sealed packs drop into cartons, which stack into cases bound for climate-controlled storage. Chocolate doesn't love heat swings, so warehouses and trucks keep conditions steady. Date codes ride on each wrapper, so retailers can rotate stock first in, first out, ensuring the texture and aroma you expect the moment you crack the seal. From the factory to distribution centers to stores, that orange flash passes through hands and scanners with one mission: deliver the same bite you remember. We've talked flavor and engineering. Now, 3 tiny moments that decide everything. Moment Hasson. The wall-forming air kiss. Too strong, and the chocolate climbs too far. Too weak, and the wall is thin. This is tuned by airflow, nozzle height, and conveyor vibration. Moment #2. The extruder blade timing. If the blade hits a beat late, the plug tails. A beat early, the plug is short and won't fill the cap. The fix can be milliseconds. Moment #3. Temper window drift. A half degree can push cocoa butter toward the wrong crystal form. Operators live on thermometers and flow curves to keep chocolate glossy, not grainy. Each moment is tiny, but together, they're everything. Miss one, and you get cups that look fine until you bite. So, when you feel that crisp shell and taste that roasted center, you're tasting 1,000 micro decisions done right. There's a reason this candy won hearts for nearly a century. The contrast is built into the engineering. Firm shell versus yielding center, sweet milk chocolate versus salty roasted peanut. It's carefully imbalanced, just enough salt to keep you reaching, just enough texture to feel homemade, executed by machines that never blink. It's nostalgia wrapped in precision, and that's a rare combo. Now that you've seen the backstage ballet from Super Sacks to the Orange Seal, what surprised you most? The over-roast origin story? The millimeter gap in the grinder? Or that air kiss that builds the chocolate wall? Drop your favorite moment below. If you enjoyed this deep dive, give it a like to help more people find it. Subscribe for more How It's Made breakdowns and ring the bell because next time, we're stepping into another everyday marvel you've probably eaten, used, or walked past 100 times without ever seeing how it's born. Stay curious. I'll see you on the line. I'm the factory line, and this is how Reese's are made.